Hello everyone. Today we are going to discuss about the concepts of phase diagram for one component water system. What is phase diagram? Phase diagram is a graph obtained by plotting one degree of freedom against another. We have already seen that there are different types of degrees of freedom. It may be pressure, it may be temperature, it may be composition. There are different types of phase diagrams available based on the number of components and nature of the materials. PT phase diagram, that is pressure, temperature phase diagram. In one axis, we will be taking pressure. In one axis, we will be taking temperature. Normally, in y-axis, we are going to take pressure. In x-axis, we are going to take temperature. This is known as PT phase diagram. Similarly, another method is also available where temperature will be taken in the y-axis, composition will be taken in the x-axis. Now the question may arise, why do we use two different phase diagrams? Under what conditions these types of phase diagrams are utilized? If the phase diagram is plotted between temperature against pressure, it is known as PT diagram. This PT diagram is mainly used for one component system. If it is two component system, we will be using TC diagram. In this lecture, we are going to concentrate only on the one component system and its phase diagram, that is pressure, temperature, phase diagram. Why do we use phase diagram? What are the uses of phase diagram? Using the phase diagram, we can understand the properties of materials in the equilibrium. Using phase diagram, study of soldering materials can be done. Similarly, we can study the phase separation techniques, solidification of metal, and change of the structure can also be change of the structure during heat treatment can also be studied using the phase diagram. What is heat treatment? While alloy making, we are heating and cooling the alloy under controlled conditions to remove all the defects that are available in the alloys. That is known as heat treatment. That heat treatment process, and while doing the heat treatment process, what are the types of changes that are taking place in the structure? This can also be analyzed using the phase diagram. Now we are entering into our concept of one component system. We have seen a lot of examples for one component system. Water system, sulfur system. These are the examples of one component system. Now we are going to take water system as an example. Water exists in three possible phases. Am I right? Water is existing in all the three phases. What are they? Solid. What is the solid water? We call it as ice. It is in the solid state. Then what is liquid water? That is the normal water. It is in the liquid state. We call it as water. And one more form is also available, that is known as vapor. When water is available in vapor state, how do we call it? It is known as water vapor. Hence, there can be three forms of equilibrium. What are the possibilities? The solid in equilibrium with liquid. What is solid? Solid ice is in equilibrium with liquid water. Liquid water is in equilibrium with vapor. Vapor is in gaseous state. Similarly, one more thing, solid ice is in equilibrium with vapor. So, different types of equilibriums are possible in water system. Now, a question of recap. Why do we call the water system as one component system? Yeah, already we have seen in one component system, example of water. Water may it be in gaseous form vapor or liquid form water or solid form ice. All the three can be expressed by a single formula H2O. That's why we call it as one component system. The phase diagram we are going to draw for this water system only. The phase diagram already we have studied, it is pressure versus temperature. Pressure is taken on the y-axis, temperature is taken on the x-axis. While drawing, we will be starting with a point. Using that point, we will be having some curves. In between the curves, we will be having areas, and the point is known as triple point. All these things we are going to explain in step-by-step manner. While doing so, it will be always better for better understanding whenever we are drawing the phase diagram parallelly. After understanding the concepts, I want all the learners to draw it on yourself, because this one component system concept is mainly based on drawing the phase diagram. How to draw that? It will be easier to follow step by step. So I am going to give the animation in a very step by step manner. Then and there you can also draw, so that at the end of this lecture you will get a clear grip and understanding about one component system, water system, phase diagram. Yeah. First of all, let us draw one y-axis line. Right? Do you remember what is the y-axis line? It is the pressure axis. In y-axis, we are going to take pressure. Right. What is the next step? In step 2, I am going to draw an x-axis line. This is already mentioned, PT phase diagram. What does it mean? In y-axis, we have taken pressure. X-axis, we are going to take temperature. Is it okay? Good. Now, we are going to point a particular triple point O. What is triple point? The name itself indicates triple point means that the point will contain all the three states of water. What are the three different states of water? Ice, water, vapor. All the three phases will be available in this point O. So the point O is known as triple point. Okay. What is the temperature? It will be existing in a particular condition, a particular temperature and particular uh, pressure. For triple point, the equilibrium is ice in equilibrium with water in equilibrium with uh, vapor. This is known as triple point. This triple point equilibrium is existing at a particular condition of temperature 0.0075. Then corresponding pressure also we have to mention, right? What is the pressure? 4.58 millimeter mercury of pressure. We are not at all mentioning it in the atmospheric pressure because it is very meager pressure. So we are representing in terms of millimeter of mercury pressure. This is known as triple point. Triple point is the point at which solid, liquid, water, all the three phases are coexisting. This coexisting equilibrium is available only under a particular condition. The temperature should be fixed at 0.0075 degrees Celsius. The pressure is filled at 4.58 millimeter of mercury pressure. What does it mean? The pressure, the degree of freedom pressure is also fixed. The temperature is also fixed. That means there is no degree of freedom for this point. This point contains 0 degree of freedom. If the degree of freedom is 0, we have studied such system will be non-variant or invariant. So it will be non-variant system or invariant system. How to prove it theoretically? We will go step by step in the next few slides. Now our ultimate aim is to focus on the first point, triple point. We know what is the temperature, what is the pressure. Drawn up to this level? Good. Now, using this O origin, using this triple point as the origin, we are going to draw one line. This line here, you please check what is happening to the temperature. The temperature is reduced. The temperature is decreasing and the pressure is increasing. Am I right? The temperature is decreasing, correct? And the pressure is increasing. You can see the line. The line is more inclined towards pressure axis. Am I right? It is not away from the pressure axis. It is towards the pressure axis. You have, while drawing the line, all the care should be taken that it is not at all moving away from the pressure axis. It is moving inside the pressure axis. Temperature is decreased and pressure is increased. Let us consider the point is C. The line OC. The first line is OC. This curve is known as OC curve. What is the pressure? The pressure corresponds to this point OC is 218 atmospheric pressure. 218 atmospheric pressure. Is it okay? Now we are putting another point A. That A point corresponds to the temperature of 374 degrees Celsius. Now you can get an idea that this line we are going to increase the temperature towards A. That means we are going to increase the temperature. What will happen to the pressure? The pressure will also increase to a particular level. That is known as OA curve. What is OA curve? When the system is experiencing an increase in the temperature and increase in the pressure, then we can say that is the OA curve. Care should be taken that C and A are not in equal pressure. C is in higher pressure region, A is in lower pressure region. With respect to temperature, C is in lower temperature region, A is in higher temperature region. So this is known as OA curve. We have started with point O, then we are having OC curve and OA curve. Two curves we have seen. Then check another curve. Here what happens? We are decreasing the pressure, decreasing the temperature. In OC, temperature is decreased but pressure is increased. Here, temperature is also increasing, pressure is also increasing. Here, temperature is also reduced, pressure is also reduced. This curve is known as OB curve. This curve is known as OB curve. The temperature corresponds to minus 273 degree Celsius. A is on the positive end, B is on the negative end. Is it clear? A, the temperature corresponds to 374 degrees Celsius. B, the temperature corresponds to minus 273 degree Celsius. Yeah. Now we are adding one more dotted line curve. Will you please draw this curve also? We will explain the concept in due course. It is almost parallel to OB. Now we mention it as the OB dash. What is OB dash? We will discuss. OC, OA, OB, OB dash. So we have started with the first point O, triple point. Based on the point, we have drawn four curves. Curve OA, curve OB, curve OB dash, curve OC. Totally there are four curves are available in this phase diagram. Is it clear? If we are following it step by step manner, it will be easy to draw the phase diagram. How did we start? We drew one y axis pressure, then x axis temperature, then point O, OC, OA, OB, OB dash, and then and there we have mentioned the conditions also. What are the conditions? 374 degrees Celsius A, minus 273 degrees Celsius B, 0.0075 degrees Celsius O, 218 atmospheric pressure C. The O corresponds to 4.58 millimeter mercury pressure also. Okay. Now imagine the concept. Water will be existing in what state when the temperature is below 0 degree. When below 0 degree, the water will be existing in ice. Okay. If it is above 0 degrees Celsius, then it will be water. When we are boiling the water, when the temperature is increased, when keep on increasing the temperature above 80, 90, 100, 200, 300, water will be in what state? Water will be in vapor state. So all the three phases have been incorporated in this phase diagram. It is the very simple or simplified phase diagram we can say. This is called ice, this is called water, this is called water vapor. Then another question arises, what is the significance of B dash? B dash is known as metastable equilibrium. That means sometimes it is possible to cool the water below 0 degrees Celsius without formation of ice. Quite amazing, right? But it is possible. It is highly unstable. The water can be cooled below 0 degrees Celsius without formation of ice. It is known as supercooled water. That is represented by OB dash, right? Okay. Now, very logical questions are arising. What is ice to water? Ice is in solid state, water is in liquid state. Then ice is converted into water. What is the name of such process? When ice is converted into water, we call it as melting. Very fine. So OC line is known as melting curve. OC line is known as melting curve. We started with what is triple point? O, one point. Point is known as triple point. Then we do have curves. OC is known as ice to water phase. That means it is known as melting curve. Okay. Now we are going to the next curve. We are having water. The water is converted into vapor. What process by which we are converting water into vapor? That is known as vaporization. Therefore, this OA line is known as vaporization curve. This is known as vaporization curve. What is O? O is known as triple point. We studied what is point O. Then OA is over. We also studied about what is OC. Ice to water is known as melting. So that is also we have studied. What else is there? OB. What is OB? OB, on left hand side we do have ice. On another side we have vapor. What is the process of conversion of a solid into vapor? We have studied in our lower classes. Camphor, it is in the solid state. Without melting, it will be directly going into vapor. Such process is known as sublimation. So, ice is converted into water vapor. It is known as sublimation method. So, OB curve is known as sublimation curve. So far we have studied 1 point and 3 curves. And already we discussed about OB dash. OB dash is known as metastable curve. What is metastable? Just now we have studied the water can be cooled below 0 degrees Celsius without formation of ice. So this is known as supercooled water. This process is highly unstable in nature. A small change in the conditions will cause formation of ice. Therefore, the water, vapor, ice equilibrium will be disturbed. OB dash is known as metastable equilibrium curve. So what we have studied so far? 1 point and 4 curves. Okay. Then in between these 3 points we are having areas. In between these 3 points we call it as the area. What are the possible areas? We are having AOC. AOC is an area. AOB is an area. COB is also an area. So how many areas are possible? There are 3 areas possible. What are they? AOC. In that area, what is available? Water. AOB. In that area, we do have vapor. Then what else is that? COB. In COB, we do have ice. One more point here we didn't mention that A. That point A corresponds to 1 atmospheric pressure. The point A corresponds to 1 atmospheric pressure. Right? So what are the areas do we have? AOB area. In AOB, we are having what? Vapor. What is AOB? This area. This area, vapor area. What is AOC? AOC is water area. COB. What is COB? Ice area. So three areas are there, such that we are having 1.4 curves, then three areas. What are the area? Area AOB we have seen, AOC we have seen, COB we have seen. So this is how we are going to draw the phase diagram. Then we can go to explanation. In each point, curves, areas, what are the equilibrium? Based on the equilibrium, using our phase rule, how can we know whether that system is non-variant, univariant or bivariant? Is it okay? If you are thorough with drawing this phase diagram, then explanation of the phase diagram and interpretation will be much easier. Yeah, this is the overall diagram for our easy understanding. Already I have seen how to draw the diagram, and this is known as your overall diagram. Okay, now we can go to explanation of phase diagram. What are the various points that are available with this phase diagram? We are talking about curve OA. First thing we will start with, at any point on the curve, the following equilibrium will exist: water and water vapor. In curve OA, we are having water and water vapor. What is the phase rule? We know what is phase rule. F is equal to C minus P plus 2. For all the points, for all the cases, what is P? It is one component system. So always F is equal to C minus P plus 2, C is 1. How many phases? Water is in liquid phase, water vapor is in gaseous phase. So we can put 2. As per the formula, plus 2. F is equal to 1 minus 2 plus 2. What is the answer? 1 plus 2 is 3. Minus, we do have 2. So 3 minus 2, that is equal to 1, which is known as univariant. So curve OA is univariant. This equilibrium line OA will extend up to the critical temperature 374 degrees Celsius. Beyond that point, the equilibrium will disappear. Then we are going to the next case. Case number 2, curve OB. It is known as sublimation curve. What is the sublimation curve? It is the equilibrium between sublimation. What are the components in sublimation? One vapor and one solid ice. At any point of the curve, the following equilibrium will exist. What are they? Ice and water. Now we know, let us assume, what is F? F is equal to C minus P plus 2. What is C? Always we know component is 1. Am I right? What is P? How many phases are there? 2 phases are there. And plus 2. So 2 minus 2 getting cancelled. F is equal to 1. What is 1? It is univariant. Am I right? Good. Apply your phase rule. F is equal to C minus P plus 2. F is equal to 1. This is known as curve OB. This equilibrium will extend up to absolute zero. The left extreme we studied, right? Minus 273 degrees Celsius, where no vapor can be present and only ice will exist. This is called curve OB, sublimation curve. What is case 3? Ice versus water. It will give you an idea. Ice versus water means that is curve OC, melting point curve. The curve OC is called melting point curve of ice. It represents the equilibrium between ice and water. Ice is there, water is there, they are in equilibrium. Can you try what will be the degree of freedom? F is equal to C minus P plus 2. How many component? One component. How many phases? Two phases. Why? Because ice is in solid form. Water is in liquid form. Right? So how many phases? Two phases. The curve OC is slightly inclined towards the pressure axis. Have you studied that? Towards the pressure axis it will be inclined. This shows the melting point of ice decreases with increase in pressure. The degree of freedom is always univariant. Why so? F is equal to what is C? One component. How many phases? Two phases plus 2. What is the answer? 1. It is also univariant system. Now comes the fourth case. What is the fourth case? The fourth case is uh, triple point, point O, which is also known as triple point. In this triple point, all the three phases will be coexisting. It is known as point O. What is point O? There are three curves OA, OB, OC. They meet at point O, where three phases, namely solid, what is solid? Ice. What is liquid? Water, vapor, all are present simultaneously. This is known as triple point. Now can you guess what is the equilibrium for this equilibrium? What is degree of freedom? Let's try that. How many phases? Three phases. How many component? 1 minus 3 plus 2. What is the answer? 0. It is theoretically proven. Sorry. Already we have seen theoretically for this triple point, degree of freedom is 0. Why? Because the temperature is also fixed, pressure is also fixed. You can't change the degrees of freedom. Theoretically also it is proven here. The degree of freedom of the system is 0, non-variant. Why? C minus P plus 2, 0. The temperature and pressure at this point are fixed. Temperature is 0.00575 degrees Celsius. Pressure is 4.58 millimeter of mercury pressure. You can't change both the pressure and the temperature. Right? Okay. And finally, we are having that metastable equilibrium curve. One more special curve we have studied, right? What is that? The curve OB is called vapor pressure curve of supercooled water or metastable equilibrium, where we are having the equilibrium of supercooled water and vapor. Next thing we will discuss about areas. What are the areas? Area AOC, BOC and AOB. All are representing water, ice and vapor respectively. In order to define the system at any point in the areas, it is essential to specify both temperature and pressure. The degree of freedom of the system is always 2, that is known as bivariant. What are the conclusions we can say? The point O is always non-variant. f is equal to c minus p plus 2, degree of freedom is 0. Curve OA, OB, OC, OB dash. All the curves are coming under univariant conditions. Why? Because in all the cases, component are 1, phase are 2. While applying f is equal to c minus p plus 2, we can say c is 1, p is 2, 1 minus 2 plus 2, f is always 1. We have mentioned the conditions also. For point O, what are the conditions? 0.0075 degrees Celsius and 4.5 millimeter of mercury pressure. Curve A, 374 degrees Celsius is the critical temperature. Curve OB, minus 273 degrees Celsius, it is absolute zero. Curve OC, it is 218 atmospheric pressure, it is known as critical pressure. Curve OB dash is the special curve. It is also known as metastable equilibrium curve. Supercooled water is in equilibrium with water. Water is cooled to below 0 degrees Celsius without ice formation. In areas AOB, BOC, COA, in all the cases we do have P is equal to 1, C is also 1 because there are only one phase are existing. Therefore, in all the cases, we are getting the F value as 2. Therefore, it is known as bivariant. This is how we are going to proceed for the concepts of phase diagram and how to draw the phase diagram and what are the conclusions that are arrived from the phase diagram for one component water system. Hope this will give you a very good and clear understanding on how to draw the phase diagram and how to interpret the phase diagram for one component water system. See you in another lecture. Thank you all.